Welcome to Study Loop.
Okay, first up, we want to prove this inequality is correct. So if x is a positive real number, then there exists n in the integers such that n squared is going to be less than or equal to x is less than or equal to n plus 1 squared. So first up, we have n is going to be less than or equal to square root of x less than or equal to n plus 1, just squaring everything. Oh, no, not less than. This is going to be strictly less than. So clearly, n is going to be equal to the floor of square root of x. Because we have n and n plus 1, we know that square root of x is going to be somewhere in this region, so we're going to take the bottom number, which is n. So now for this side, n squared, so the floor of n squared is going to be less than or equal to the floor of x, which is going to be less than the floor of n plus 1 squared. Then what we'll do is the floor of n squared is just n squared, so that's less than or equal to the floor of x. So that's going to be less than the floor of an integer is still an integer, so it'll be n plus 1 squared. Then taking square roots of everything, we have n is less than or equal to square root of floor of x, so that'll be less than n plus 1. So once again, we are bounded once again between n and n plus 1, so we'll just take the bottom one. So therefore, the floor of square root of floor of x is going to be equal to n. But we know that n is equal to this number already. Oops, sorry, equal to floor of square root of x. So therefore, the equality follows. Now, we want to prove the ceiling of x is equal to ceiling of square root of x. So in the same sense, we will bound x again by n squared is less than x, less than or equal to, less than n plus 1 squared, square rooting everything. So we have n is less than or equal to square root of x is less than n plus 1. Taking ceiling, we take n plus 1. Sorry, we don't want the inequality, we want the inequality this way. So yeah, we take the ceiling of everything, so then ceiling of square root of x, we then take the upper bound, so this will be equal to n plus 1. For the other side, ceiling of n squared is going to be less than ceiling of x, which is going to be less than or equal to ceiling of n plus 1 squared. These are integers, so they are just themselves, since it's less than or equal to n plus 1 squared. Taking square roots of everything, n is less than square root of ceiling of x, which is less than or equal to n plus 1. And ceiling of this again gives you floor of ceiling of x is equal to n plus 1. But you know n plus 1 is already this number, so this is ceiling of square root of x, so equality follows.